Hello everybody, my name is Satvik. I am from VIT University MTech CAD CAM. Today's seminar topic is various manufacturing methods which comes under additive manufacturing. Additive manufacturing is a latest technology where the whole of manufacturing process is made into a very simpler and faster process. Let us see the process of additive manufacturing and compare it to the other conventional manufacturing methods which are available with us. So let us start with the seminar. So this is the overview of the seminar where starting we learn about the manufacturing, types of manufacturing, additive, and explanation about additive manufacturing and how it's done, and comparing other manufacturing methods with the additive manufacturing. Okay, manufacturing. What is manufacturing? Manufacturing is just an application of physical or chemical process to alter the geometry, properties or appearance of a given starting material to make parts or products. We can see from the diagram that a starting material is used, many forces are used on the starting material to change its shape and its property and geometry to make it appear as a new part. So the whole process of this, from the starting material to the final product, is called manufacturing. As you all know, there are many types of manufacturing seen in mechanical engineering, namely casting, forming, machining, joining, powder metallurgy, non-traditional machining, and finally additive machining. These are the conventional manufacturing processes which are there from a very long time, and let us see how these manufacturing processes works and how it makes a difference with the additive manufacturing. So let us start with forming. Forming is nothing but a type of manufacturing where raw material is given a mechanical forces like hitting or pressing. By giving these mechanical forces, the shape of the raw material is changed into a shape which we need. As you see in the diagram, there are many types of forming, like rolling. Rolling can be hot or cold, or drawing of wires, or the other forming processes like pressing, hot pressing and cold pressing, etc., extrusion, etc. So this is basic about forming. So now let us go to powder metallurgy. Powder metallurgy is a process where the metal powders from two different metal powders are combined to make a single metal, where the properties of the two metals are combined to make a single property. Here what we do is the metal powders of two or more metals are taken, and these powders are mixed according to the stoichiometric ratio. Then after mixing with the stoichiometric ratio, it's pressed and given using binders. It's compacted into a normal billet shape as we see in the photo. After it made into billet shape, it is heated to a particular sintering temperature according to the property of the individual metals. After its sintering is done, this material is again tested for the mechanical properties. While testing mechanical properties, we can find out that these mechanical properties which are obtained by the final metal is the combining of the material properties of metal A and B, which is taken as a starting material powders. So the other machining processes in general include drilling, cutting, burnishing, and hobbing, and grinding, etc., where the main process, what happens here is subtraction of metal and not the addition of metal. As we see in additive engineering, it's only of adding the metal, there's no subtraction. Here there's a standard shape. From the standard shape, many machining process, as I said, drilling, cutting, grinding is done, and the metal parts are removed, and shape and dimensions of what we need is achieved only by subtraction. So let us now move on to non-traditional machining. Non-traditional machining is another machining process where the normal cutting and drilling conventional processes are not used, but other than these the processes are used. Like example, like ultrasonic machining, that's USM, water jet machining, abrasive water jet machining. Then in thermal, if we see, it's electron beam machining, laser beam machining, ion beam machining, plasma arc machining, chemical machining. So these are the general types of non-traditional machining which are available for us. So let's see the brief photographs of diagrams of the NTM, non-traditional machinings. And my towards the left we can see that it's ultrasound machining, where ultrasonic machining, sorry, where high frequency is given to the transducer, where it vibrates in high frequency. This vibration is used so that this vibrational force is used to drill or make an impact on the workpiece, which brings in the shape as the tool. And then the next one is water jet machining, where water with high pressure abrasives are put on a certain workpiece and groove, so that the groove is formed. So these till here are the basic machining processes which are available. Now let's go to the special process, that's additive manufacturing. Additive manufacturing. The additive manufacturing is also known as rapid prototyping, where it's used to quickly fabricate a scale model of a physical part or assembly using 3D computer aided design. That's CAD. CAD, as we know, are softwares which where we can make any process in the software form, any product in a software form. The many softwares are namely CATIA, SolidWorks, Pro Engineering, etc. Using these softwares, we can model the shape of the final product we want to achieve. Using these final product designs, using the softwares, we can make any shape as we needed without any machining or cutting or any other process as such, and it's a one-shot process. Now in the diagram we can see a stereolithography process, where the stereolithography process, where a single shot manufacturing is done. So now let us go deep into this process. In this process there are 6 steps, where as we see in brief, it's CAD. For the first one is CAD solid model. CAD solid model is nothing but as I told before, it's a process of designing or giving a shape of any product that we have in the mind using the softwares like CATIA or in CATIA Pro E, etc. These solid models are in the IGS forms, should be taken into a next level, where these IGS forms are converted into STL files. STL files are nothing but the files which are 3D printing machine friendly, so that every 3D printing machine in the world use STL files to make the 3D model. So it's very compulsory to make a CAD model in any form into a STL file form. So once the model is done in STL file form as a software, it's introduced in any 3D machine. In this 3D machine, the machine will go into the process, go into the STL file, read the file, understand what it wants to do, then the machine starts doing it. So machine first makes a lot of file slices, like 2D slices. These 2D slices is called as slicing. These 2D slices are later built up one upon the other to make a 3D format. Like you can imagine a cheese slice, where a single cheese slice is piled upon one on the other to make a bundle of cheese slice, which is finally seen as a cuboid slice. So this is the basic principle which is used by the 3D machines. So this after slicing, the next process is the build-up. After the slice up, all the slices are compacted and a building is done. And after this build-up is done, there is a fabrication of the part. The the part is done, and after the part is done, it's taken out, and these 3D machines are done using many supporting structures and many other outside structures. So using all this a post processing is done where the support structures and all are removed, and finally the model is ready. So these are the pictures about the 3D machine. To my left is the process as I explained. It's the 2D slices which compact and become a 3D slice as I told before. And right side is the machine where everything is done. The STL file is given into the machine, and the machine gives out the output and the 3D model completely after the process. So here in this photograph we can see the complete process, where towards the left top corner is the right top corner is modeling done of a house roof, where this is being converted in a STL file. This STL file is put into a machine, 3D printing machine, where this STL file is being produced. After produced, there is a last final structure of already the finished product. So here are some more photographs. The right side pictures of the semicircular and the laser beam methods are the methods which are used in 3D printing. Laser beam method is using laser to bring in the shape, and this is the accuracy which we can see as we see in the semicircle, how the slices are placed and how it's produced. And the other one is the blue and yellow color is the CAD model, which has been designed in the CAD softwares. And seeing the other diagram as other picture, the shoes, where shows us that there's no limit in designing the 3D printing. Any design, any complex shape can be done in just single go. So now we come to the comparison, where additive manufacturing is compared to all other manufacturing processes. The first main comparison difference we can see is additive manufacturing is a additive process where the material is added into added slice by slice to make a final product, whereas all other manufacturing processes like cutting, drilling and all is a removal process, where subtraction process where the metal is removed. The second main advantage is as we see is the CNC machines and other conventional techniques. A single product such as silencer, you need 3 or 4 levels to finish the complete product, where the sheet metal has to be bent first, then the hole has to be done, then the welding has to be done, and etc. etc. So this is the many processes has to take place one after the other, and many machines are involved. But in additive manufacturing, the whole design is put in as a STL file, and the whole silencer comes out as a single shot process. So this is the main advantage. So let's go to the material part of it, where conventional machines and other CNC machines can be used only for very strong metals, materials like metals and others, whereas additive manufacturing has a wide variety of materials that can be used in it. Example, it starts from polymeric materials, waxes, to ceramics and composites. So all metal which are also soft can be used in additive manufacturing. Now comes the speed. As I told before, there are multiple stages in normal conventional manufacturing and machining, CNC machining, but in rapid prototyping or additive manufacturing, it's the whole process is done in a single shot. So when the whole process is done in a single shot, the time taken is lesser. But there are other aspects where the cutting process, where you have to make a triangle, or a trapezoid, you can make a cube and cut it into the other parts can be taken off, and this is fast. But in rapid prototyping, if you see that same process, making a trapezoid can take a little more extra time, but that's the constant time. So now we come to the complexity. Additive manufacturing, we can make any complex product, as we have seen before in the photographs. When we come to the accuracy, again everything is done with the help of the software, where the software has doesn't have tolerance. It's completely tolerance free. Every product has zero tolerance accuracy, and this can only be achieved through additive manufacturing. So now we go to the geometry. In the geometry, as we all know, first additive manufacturing uses 2D slices piled upon each other to make a final 3D product, whereas in conventional machining, conventional techniques, already a 3D raw material is taken and shaped into a product as we want. In programming, where again when we see in the CNC machine, we need to give programs for the tool selection. There's a separate program for tool selection, there's a separate program for machine speed settings, and there's again a separate program for approach of position, angle, and again there's a separate program for post processing. Whereas in rapid prototyping, there is only one program which is converted into STL file, and this program has to be STL file. The program reads the STL file and makes a single program, where the whole single program is sufficient to make the whole product. So that's it. As we see that the conclusion is additive manufacturing has a lot more advantages than disadvantages compared to normal conventional techniques. So the technology has improved and given us easier way to manufacture prototypes and materials in the form of additive manufacturing. Thank you.